Hi, everyone. So today I want to talk about the current landscape for integration. What, if anything, has changed over the years? In particular, what kind of impact has the popularity of event-driven architecture had on integration? And later, I'll dive into the seemingly disparate topic of low-code development. We'll look at controversial questions like, does low-code overpromise and underdeliver? Who is even asking for low-code apps, if anyone? I'm Rachel. I'm a software engineer at Red Hat. Some of you might remember me from last year when I presented with Christina Lin about leveraging the Camel ecosystem to solve cloud-native problems. This year I'm back, but I want to talk a bit more about building integrations in the cloud, making it accessible to people with low-code development. If you're here, then there's a good chance that you're already familiar with Apache Camel. If you're not, I'll give you a quick overview anyway. So Camel is an integration framework that makes it easier to connect multiple systems, where a system can be really anything from a web service like Salesforce to a database or data warehouse. In the world of integration, we have to repeat a lot of the same tasks over and over again. Those tasks can really be anything from configuring a connection to a new API or aggregating and splitting data from multiple systems. These repetitive tasks have common design patterns in their solutions. These are called enterprise integration patterns, or EIPs for short. And they are what Apache Camel has been built around. So why are patterns so important? For one, they provide a proven solution for a very specific problem. But more importantly, they make it much easier to communicate by using common semantics. You can also extend Camel to understand any system by creating a component. You can see that this has been done already quite a few times, considering there's over 250 components to date. Components provide you with specific implementations of an API that target different protocols and data types. Standing at only 4 point something megs, Camel is quite light considering how much it does. Camel has also evolved quite a bit over time. In particular, there's been an increased focus on developing cloud-native integrations with it in recent years. Let's not forget that it also has a test kit for developers, the same one that is used to test Camel itself. And that thing has over 18,000 unit tests. It's definitely not the kind of thing that you roll out yourself in-house. At a high level, Camel has 3 core concepts. It has routes, processors, and components. All of these are contained within the Camel context. And at the very core of Camel is its routing engine, which allows you to define your own routing rules. And it makes no assumptions about what kind of data you're going to be working with. The Camel context in and of itself has several services within it. For example, the one that contains the components that you define and are using. Here, we're looking at a flow of an exchange through a route. A kind of strange thing to notice is that the route first starts with a consumer, and then producers are at the end of the route. If you're familiar with Kubernetes and Kafka, actually, got that the other way around, you know that producers are in the beginning and consumers are at the end. But the key thing to understand here is that you have to look at it from the perspective of the external systems that it's communicating with. So consumers are the ones that are actually consuming the messages from external systems and bring them into the route. Then the producer sends or produces the messages to the external system. Finally, what allows the exchange to the external system is the actual Camel component. A few years ago, there was an initiative to create a level of abstraction over Camel routes to sort of hide the complexity of building integrations. The motivation was that sometimes it's easy for higher level users to get confused with the sheer number of parameters to configure and requirements for certain systems. As a remedy to this problem, Camelets were created and released as a part of CamelK. Camelets are essentially camel route snippets. They are a template of a camel route. So it lets you preview kind of a part of the route. And the main focus of it is reusability and simplicity. But the underlying motive of it is the ability to abstract. Camelets kind of force you to keep it simple, and that's really what we want. One of the best practices for building integrations is to build more and build smaller ones than less of them and let them grow out of control. Out of the box, Camel has hundreds of components, and many of those are for connecting with SaaS providers like AWS, Firebase, etc. Camel can listen to and trigger cloud events. So for those of you that are interested in event-driven systems, don't rule Camel out. But with CamelK, one of the Camel subprojects, you eliminate a bunch of the friction that comes with building cloud-native applications, since it already does a bunch of things for you, like dependency management. And if you really are into all things event-driven, you've probably heard of Knative. If that's the case, you'd be happy to hear that it's possible to run an existing CamelK integration as a Knative serverless service. Through Knative serving, you get introduced to the idea of scaling to zero, scaling up for load, so that you don't have to predict your workload. And then you have Knative eventing, which serves as the new specification for future cloud events. The nice thing about all of this is that your service just receives messages through incoming cloud events without having to actively connect to the broker. So it's a passive service. It's also smart enough to discover any resources required to run your application. For instance, let's say that you have an API and it has certain endpoints. If you expose an HTTP endpoint in the app, CamelK will automatically create a related service and route on the platform for you. Likewise, if you stopped using one of those resources, you just delete it and CamelK will clean up for you. And of course, it also removes the need to configure Docker or S2I before deploying to OpenShift or Kubernetes. Oh, and by the way, one thing I really want to be clear about is that even with event-driven, you should still be using a framework like Camel and following best practices with enterprise integration patterns whenever you can. So, okay, that was a lot to learn. One of the things that this ecosystem has is a bunch of awesome technology, but it can be improved. And I think that one of the ways that it can be improved is by being more readily accessible to people in a way that's easy to understand and work with. So since I've mostly been working on the front end in the past 5, maybe 6 years, I've become a lot more needy and just kind of wanting things to be as easy as possible when it comes to technologies like this, because it's just so many to learn. And honestly, at first it's nice to learn something new, it's exciting, a new language, new framework, but it gets to be a lot pretty quickly and you get drained fast. This is a huge challenge, especially for front-end developers. How do you prioritize what to learn? And to me, low code is one way to address that. Can I still automate some of the things I'm doing in my business area without burning down an entire server farm or without breaking production? We should know when to say, we build everything ourselves, and when to say, here's how to build it yourself. It's about accessibility, and that includes developers and non-developers alike. This chart you're looking at is from a Harvard Business Review article that was published around 10 years ago. And it was about something called shadow IT efforts. And the idea is that you have a very impatient business analyst or a marketing manager using their department budget to pay for a third-party solution, just in order to be able to automate different business processes like customer relationship management or, I don't know, supply chain reporting and social media analytics. The reality is that not that much has changed in over 10 years with this respect, because organizations are still having these issues. The Harvard Business Review actually published an article just a year or so, maybe I want to say, yeah, about a year or so ago, just to follow up on that 10-year article, talking about how low code can even help to fill a gap in the so-called great resignation that has formed since COVID. It's actually attributed to a huge uptake in low code development platforms since the beginning of the pandemic, where we saw lots of workers leaving their jobs for greener pastures. And I don't know how seriously to take Gartner insights, but they're kind of predicting that by 2025, 70% of new applications developed by enterprises will use low code or no code technology. That percentage, it used to be less than 25% in 2020. Combine that with Morgan Stanley's report that there's a worldwide shortage of software engineers by at least 10 million in 2024. And we're going to need to start taking low code a lot more seriously, a lot sooner. I just wanted to quickly show a summary chart from the IDC group. It's a research group. And this shows integration and API management being the second biggest area of investments for enterprises when it comes to low code. And that's about 44% of those that are planning to increase the spend on low code and integration. The key here being that low code is being taken seriously by a number of organizations, quite large ones, particularly within the integration space. But the white elephant in the room is the misunderstanding around low code. So when I used to hear about low code development, my mind often translated that as, well, it's just another tool that overpromises and under-delivers. And that's because us developers have been told since maybe the 70s that low code is going to put us out of a job and AI is going to take over. So I guess we're a little bit scarred. And it contributes a bit to the misconception that low code is not for developers. And of course, as with most things in software, it really depends. You get developers that are burned once and never want to touch low code ever again. And I don't blame them, really. You also have more pragmatic folks with concerns about vendor lock-in, and rightly so. So what can be done about that? It's not like low code is going away anytime soon. One thing that needs to change, though, is that we need to manage our expectations. So low code will never have the same full features, kind of native features as a tailor-made application. And we kind of have to accept that. But it lets you get to work quickly. And it lets you work with people that are either not developers or that are not familiar with a particular programming language or framework, like Apache Camel. The other thing, and of course, I'm biased here, is to choose tools that are built for purpose and that do one thing and one thing well. The most important thing, however, is to choose open source low code tools. And I'll tell you why. For me, the solution to vendor lock-in is easy. Work with open source. Most of the time, people start using low code applications out of necessity. They might be understaffed or limited in time or money, but they have to get something done. So what happens? A few months or years pass with using a low code application, and they've reached a point where their requirements are maybe beginning to exceed the capabilities of the application. But chances are the app is proprietary and closed source. So any enhancements that are made need to be done by the company or the person that developed the application to begin with. That's the kind of vendor lock-in that is often associated with low code and no code solutions. This wouldn't happen for open source because you could always hire a developer to extend or maintain the tool if you were that desperate. Chances are, if you need it, someone else in the world does too. And that's the awesome thing about open source. It knows no borders. And you may be thinking, well, I thought the point was to avoid hiring a developer, but actually it's not. The point is that low-code applications are a means to an end, or at least they can be seen that way. They are a way to get to where we need to be. And if you look at the alternative, we're talking a lot more money for a custom solution and vendor lock-in for one that's ready-made. Neither of those, at least to me, are viable solutions. At least with open source, you have options. And always remember, the best low-code tool is one that actually has an off-ramp to a more robust solution, one that gives you an out when you're going to need it, because you likely will. We built Kaoto because we were working on a project that was intended to be an integration platform, but it was far too limiting for us. We couldn't run it where we wanted, and we felt very restricted in what we could and couldn't do due to requirements we had at that time. Some challenges were in dealing with the exchange of data between the front end and the back end. And ultimately, this ended up impacting the user experience as well. So with that, we built a cool little app that does something very specific and allows you to build integrations visually with or without code that you could easily deploy to the cloud. We wanted it to be developer friendly. So you have the option to choose a particular DSL from the settings, say if you wanted to work with camel routes instead of camelets. But the main thing is that we wanted to create something that could evolve over time. So for example, it needed to be open source. It needed to be extendable even for those who can't code, or at least to have as low of a barrier as possible for them. And of course, we wanted it to be simple. We wanted it to just be, a visualization canvas, and then you have access to a code editor if you want something a bit more. And then of course you can configure the DSL and everything for something a bit more advanced. So what you're looking at here is that on the left, we have a catalog with available steps or camlets you can drag and drop to configure. You always have access to the code, which is in YAML for now, because that's what Kubernetes uses. And of course, you can deploy your integrations to the cloud. If you use OpenShift, we have an operator for Kaoto as well. One thing to keep in mind, though, is that it's still pretty early days. So we're regularly improving on the user experience and flexibility of Kaoto. With that said, if you are either a React front-end developer or a Java developer, we're actively looking for contributors. So if you're interested, reach out to me, whether it be on Twitter or of course, just go to kaoto.io, the website, or GitHub, which is linked on the slides. I mentioned that one of the things we wanted with Kaoto was the ability to extend it easily and to do that easily. And for that, we've architected it in such a way that it uses an external catalog for the steps that you see on the left-hand side. Of course, a catalog already comes out of the box, but the point is that you can still point it to your own GitHub repository with your own catalog of Camlet if you wanted to do so. And you also get validation of what steps you can and cannot use. So ultimately, you could even use it to learn more about Camlets and Camel in general. One of the awesome things also about Kaoto is there's no persistence layer, which means you don't have to deal with a database or severe security issues the way that you would if you were dealing with a traditional relational database management system. And it also makes it quite portable. We're working on a VS Code plugin. We are doing lots of things. So make sure to keep an eye on that. So I want to show you a demo I recorded with my colleague earlier this week. And in it, I'll be sort of pretending to be a citizen developer, meaning that I know how to code, but I'm using a low-code tool, Kaoto, to build integrations quickly and in a collaborative manner. Keep in mind, as the citizen developer, it means that I am not familiar or very familiar with Camel, and I'll be working with my colleague, Maria, who is the Camel expert in this case. Hi, everyone. Okay, so today I've been asked by my manager to create a system that allows the public to report suspicious activity in the area. And then that report then gets sent to a machine learning service that we have that will determine if that activity is already on our radar, and kind of any information about it will be returned. Also, we want to be able to provide, we also want for users to be able to report it through different channels like chat and email. So here, I'm using a cool tool called Kaoto, and Kaoto allows for me to create these integrations without coding anything unless I want to. So for the first platform, we can start with Telegram as an example. So we would just build it this way, drag and drop it onto here, configure, put our authorization token and everything in there. And then there's quite a few steps that we have to do for the machine learning service. It would involve definitely like an HTTP sync and some other queries in there, which this is straightforward enough. This looks good. So what's the problem with it? Well, I did say that we wanted to have different reporting methods like email and chat. So all of the steps that we would have to configure for the machine learning service, we would have to repeat for each of those. So, I mean, it's not ideal. But thankfully, we have our Camel expert on the call, Maria.
Hi, Rachel.
Hi, Maria. So what I'm looking for is I'm creating a system where the public, they can report any suspicious activity through different platforms like Telegram or email. And then that gets sent to our machine learning service that will then return any relevant information and say, yes, this was on our radar, or no, it's not. So what I want is, I don't want to have to configure that machine learning part for every single integration that I have to do for each platform. So is there something that can kind of save time for us on this?
Sure. I think the best way to approach this is to create a new step, like the steps you have seen already in your catalog, but a new step that does exactly what you want to do with this machine learning system and everything. And then you can use this step that will act as a black box into your integration. This way, if in the future you change the method, you change the algorithms, you change the endpoints, you can just change that step, and then you just have to rebuild the integrations you do, but without having to redo the integrations by itself. So this kind of step, which is called a camelet, can also be done with Kaoto. So let me share my screen so you can see how I'm doing this. Is it sharing? Yes. So as you can see, this is a normal Kaoto. I can refresh it. The first thing I need to do is, in the settings, change the type of thing I'm doing, because I'm not doing a camelet binding, which is an integration, but I'm doing a camelet, which is a step in that integration, in that camelet building. I'm going to change the namespace. So we use a namespace that is common for both of us, and that Kaoto has privileges to deploy it to. I'm going to change the name of this, I'm going to set up the name of this step, which is going to be criminal machine learning something. It detects if this is not a valid Knative Kubernetes resource name. And I can add some description like this will act as a black box to report suspicious activities. And now I can start with this camelet, this step, which by itself is going to be like an integration. So it's going to represent different a workflow of steps. And as you can see, the types of steps I have in my catalog are different from the ones Rachel have, because I'm doing a different thing. I start with a camelet source, which means it's expecting that I am going to have a previous step in the integration. So the Camelot source kind of links to the previous step. And now, well, I can already see the source code that is being created. It added some default data, like some default image for this icon that appears here on the steps. And if I go down, I can see that I already started with a Camelot source, and I don't have any more steps behind that. It detected my name. And I can start adding some other steps, like connecting to the HTTP endpoint that is going to be the machine learning thing. And I have the URL already here. It's very long. And I'm going to post to this URL. And you can see that this is being automatically generated here on the source code. And once it didn't detect the post. I don't know why. Yes, it's there. And now this endpoint will return a number. This number is going to represent or identify the criminal we think is related to this suspicious activity. And we want to connect to an SQL database that will extract information related to that criminal. So for this, we are going to do an SQL query. And we are going to use a data source bin. What is a data source bin? Well, this is something that is an object that will contain the name, username, password, and URL. And I can define it here on the source code. So it's a bin. I use the name, ds bin, and it has a username, a password, and the URL where the database is. This, as you can see, Kaoto has detected some dependencies that we will need to deploy this integration. This is needed on the steps because this gets deployed via Apache Camel using Java. And but it didn't detect that this is a Postgres database or that we are using this type of data source. So I need to add manually a couple of dependencies more here. And these dependencies will be added, obviously, to the list of all the dependencies that are needed. This SQL returns an array of elements and an array or a list of rows from the database. And what I want to do is access the first one and extract the attribute that contains the information we want. So for doing this, I'm going to use a set body. This set body, what it does is replace the message that is flowing through the workflow of the integration by whatever I say. In this case, okay, I have this here. It's going to be, I get the body, I extract the first element of this array that the SQL is going to return, and I extract the info attribute. Well, now we have the text. So I'm going to return this to Rachel's integration. And to do this, I'm going to use Camelot sync. So to summarize it, what this does, it's a 5-step integration, and it first connects to this machine learning endpoint that gets everything that is sent via Telegram, mail, S3, whatever we connect to. And then with the result of that endpoint connects to a database, then it gets some information. We transform that data that comes from the database, and we finally go back to the integration so Rachel can maybe respond back to the reporter or whatever she wants to do. I'm going to check that the settings are right. Maybe I can do something else, which is a property. I'm not going to really use this property here because this is a fairly simple integration. But so you can see that here we have properties. If I add one property here of type string, it will act when Rachel uses this step in her integration inside Kaoto. When she opens it to configure it, it will show a text field like this one that has a title, a description, so she can configure it, and we could use this do me property here if we need it, which we are not doing, but just to show you that this can be done. And well, let's deploy this. If I deploy this, it means that I'm pushing this to the cluster, so it will be available for Rachel there. And you can see that it's running on the list of potential camelets that can be used. The rest of the camelets you can see here, they have not been deployed by us. They have been deployed by CamelK when it got installed in the cluster. But the important thing is that this this camelet just acts as one of these other camelets that are given by default. So our camelets that we create, they will have exactly the same treatment, exactly the same properties or features that any of the other camelets. And I think that's it. You should be able to see it in your step catalog. So Rachel, if you want, you can continue doing your integration.
Awesome. Thanks so much, Maria. So let's then go back, and I'm going to refresh it so I can clear everything. And obviously want to make sure I'm on the same namespace as Maria so that I can access the step. Okay, so then we go back to what we were doing originally. So this would mean we just start again with our Telegram example, just drag and drop into here. And then the difference is that then we would want to have, we would use the awesome step that Maria has just created for us that will save us a bunch of steps. And then for fun, we will have Telegram respond. So the sync will be Telegram as well. So then obviously the next thing is I want to just make sure I have the authorization token. We can obviously see here the dummy property that Maria has included for us as well. And then adding another authorization token here for Telegram sync. And I'll give it another name just so I know that it's my integration. And with that said, I guess we can go ahead and deploy it. But so this will take a few minutes to deploy because it's installing the dependencies and everything like that. But one thing that I want to comment is that you can see how much time this has saved us because there were like 3 intermediate steps that Maria had just in this Camlet alone. So so you can see that if I had, for example, 5 different reporting mediums I wanted, like email and chat, Telegram, I don't know, WhatsApp, then that's 3 times 5. That's 5 steps that, I'm sorry, that's 15 steps in total that we are being saved and not having to configure for each and every time. So it makes it very, very reusable. And so I think Maria is also monitoring the deployment for me as well. So
yes, so maybe you can show the list of deployments so you can see that it is building. This building phase is something that what it does is no, it just changed the status. That's why it says invalid, because it was changing to building to running. Sorry. So this building, what it does is just checking all the steps that we have defined in the YAML and getting all the dependencies needed and deploying it on the cluster. So sorry, Rachel, continue.
No, that's awesome. So yeah, we can see in the logs here that it is running now. So then the next thing is that we will just go to test it. Like we're going to pretend we're a user. We are, I don't know, sitting in the park. We've seen some suspicious activity. So here, this is the Kaoto bot, and I'm going to communicate with it. So you can see here from a previous message that I had sent, it's already responded to me. But I can say, hello, there is suspicious person. There is a suspicious person looking inside of people's cars. Perfect. And so we've gotten a response saying, yes, we have recognized this person. And this is potentially an accomplice that they have to keep an eye out for them as well. So that's awesome. Then this definitely saves us a lot of time. And what's good about this is, like Maria said, if ever we were to change to maybe not use a machine learning service or a different one, then it would be a matter of just swapping out the steps inside of the Camlet, and we would not have to change anything in these integrations. So definitely a very valuable tool to have. And that's it for today. That concludes our demo. I hope this was helpful, and thanks for watching. And that's it for today. I hope you enjoyed the presentation, and feel free to tweet me. Of course, I always love to hear feedback, and I hope you found the presentation useful. Thanks again. Bye.